Now, Newton's third law of motion states that if an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. There's an alternative and more famous statement of the third law of motion, that is, to every action there is an equal and opposite reaction. Now, here we can see there is not just one force acting, but there is a pair of forces known as action and reaction forces. Important point again, action and reaction always acts on two different objects simultaneously. Let's understand the statement by some examples. Have you ever been on a boat ride? What happens when you jump off the boat? In which direction the boat moves? Try to remember. Okay, let's have a look here. Now here, when the man jumps from a boat, he applies force on the boat due to which the boat moves backward. Now this is an action done by man on boat. Now as a reaction to this, an equal and opposite force is exerted by the boat on the man, which helps the man to jump out of the boat. Newton's third law also explains something as basic as walking. When we walk, we push the ground below us backwards. Now, this is an action force done by us on the ground. As a result of this, the ground pushes us forward. That is, a reaction force acts on our foot, which helps us to move forward. When a blown up but untied balloon is released, the balloon moves forward. Why? Let's understand this by Newton's third law. So, when a blown up but untied balloon is released, the air trapped inside the balloon pushes out of the open end, causing the balloon to move forward. So, here the air escaping backward is the action done by balloon on air. Therefore, according to Newton's third law, the movement of balloon in forward direction is the reaction force done by air on balloon. There is an important note here. Though action and reaction forces are always equal in magnitude, they may not produce acceleration of equal magnitude, as each force acts on a different object that have a different mass. From second law of motion, we know force is a product of mass and acceleration. Therefore, acceleration is equal to force upon mass. Here we can see acceleration and mass are inversely proportional. That is, smaller the mass, greater the acceleration. Let's understand this by some examples. When the gun is fired, it exerts a forward force on the bullet. As a reaction to this, the bullet exerts an equal and opposite force on the gun. But when we look at the change in their velocities, that is, the acceleration produced, there is a huge difference. Why? Since the gun has a mass much greater than the bullet, the acceleration produced, that is, recoil of the gun, is much less as compared to the acceleration of the bullet. So here we can understand that if an object has more mass, the acceleration produced with the force of same magnitude will be much lesser than an object with less mass. Now take a moment to think that which law helps us in swimming. If you got the answer, comment down.